Introduction to HTTP 2.0. In this video, we will discuss a little bit what HTTP 2.0 protocol is. So let's have a look at it, what it really is. It's an HTTP standard, a protocol, communication standard, which was established in 2015, and it was following the previous standards 18 years later. The very first HTTP protocol, which is used for the web, was established in 1991. It was 0.9, and as usually versions which are less than 1 are experimental versions, and HTTP 0.9 was essentially an experimental version. The real first version of HTTP was standardized in 1996. And 1 year later, it was extended, so it became HTTP 1.1 in 1997. The major difference between 1.0 and 1.1 was that 1.1 allows a header named host. And using this, the client can tell the server that which virtual server it's interested in. So with HTTP 1.1, web hosting was available, and one server on one IP number on one single port could serve several differently named web servers. Therefore, Google started and suggested a protocol which was an extension of the HTTP original protocol, but it was not a standard, but they gave a name to it in 2009, and it was SPDY, which you simply read speedy, which means it's speedy, it's fast. And there was a version 1.0, and then in 2012 there was a version 2.0, and the actual HTTP de jure standard 2.0, which was finalized in 2015, was more or less based on this speedy protocol. But why did we need this 2.0 protocol? The 1.1 protocol was downloading requests in a single TCP channel for each resource. So if I needed a resource, if the browser needed a resource, then the browser was opening a TCP channel to the server. It downloaded that resource, and then it closed the TCP channel. And because TCP channel build-up needs a SYN package, which is sent over the network, and then the server replies with a SYN ACK, and then the client again sends an ACK. So there is a three-way handshake. It's slow, it's time-consuming. And after this, the TCP protocol is also very shy about sending huge amount of data. At first, it just starts to send some data, and then it waits for the client to acknowledge it, that it arrived. And this way, HTTP 2.0 has some important new features like header compression and multiplexed streams, which means that if I have a TCP channel, I can use that same TCP channel to download multiple resources, but not only one after the other, because if one resource starts to download and then it gets stuck and it doesn't download anymore and waits, and only after a few seconds it continues to download, then I have a gap in between. And multiplexed streams can fill in these gaps. So the resources come down as they can come down. And there is also a new feature, which is server push. And we will discuss server push, and we will have an example in the next video. Compression. HTTP 1.1 can compress the content, but it cannot compress the header fields. And HTTP 2 can also compress the header fields, and it saves even more bandwidth. Multiplexed streams. In non-multiplexed streams, occupy a TCP channel for a single resource. And then we download a next resource and the next one. But when it's multiplexed, then all the resources come on the same TCP channel, and then they download much faster. Server push. The server may anticipate that a resource that the client needs will need other resources even before the client knows it. The server, for example, sends an HTML page that references several pictures. And this is actually the example that we will look at the next video. Then the server knows that these images are referenced, so the client will need it. And it also knows that the HTML page, it's standing down, is calculated. It's not just a static HTML page, so it will take really long time until it's preparing it and can start to download. Therefore, the server says that, okay, I will send you this HTML page you were requesting for, but in the meantime, while I'm preparing it, here is some more content that you will need it, believe me. And then the client stores these in the local cache, and then the client uses these cached resources when it needs them. So if we look at this diagram again, then there is a client, and then the things are pushed down, and then the page arrives, and then it's displayed instead of downloading the page and after that fetching individually the images.